for us beginning. All right. The plan today is to go through the examples for the component pattern here and to implement them in Rust. Now, I know that like the first part of this pattern used inheritance, and we're kind. Oh, we might not be able. We might be able to do it because, yeah, we're passing in like world and graphics, and then we're splitting them out into different components. So let's do the exact sort of pattern that we did yesterday, where we have our struct Bjorn. So we're gonna have a struct. I'm gonna do this all on one page because it'll make it easier for us to sort of like just use them, go back and forth. So we have Bjorn. Bjorn takes in sort of like has an internal velocity. So velocity, which we happen to know is an X and a Y. I could just do this as a tuple. So it has like an F32 and F32. I mean, I guess I could also do this as an array. An array might make sense too, but a tuple. And then we have the X and the Y locations. So we have X, which is an F32, and Y, which is an F32. We have this update method for it. Okay, so impl Bjorn. I mean, the first thing I'm thinking about is having a constructor essentially for this. So we'll do pub function new. We're not gonna take in, like we could take in the X and a Y. 32, the Y, yeah, 32. We're gonna return Bjorn. And then we're going to just Bjorn. We'll have our velocity, which is 0.0, 0.0. We'll have our X and we'll have our Y. And that will be that. So to use this should be pretty simple. We should be able to just say let Bjorn equals Bjorn new. And then if we say like, okay, you're in like the middle of the screen or so, maybe you're 0.0 and maybe like 250.0. Now, of course, you're upset because we're not using you, but that will come later. Now we're gonna have this update method. So pub function update, and here we're gonna take in a world. So can't take in a world without actually having a world. So we'll have a struct world, and we don't necessarily know what's inside of here. So in update, we take in a reference to the world. And also the same thing for graphics. So struct graphics. And a reference to graphics. And then this doesn't seem to be doing anything for this. Oh, right, because it gets implemented down here. So we can actually come and take a look at what it's doing here. So update doesn't return anything. We take in the world, we take in the graphics. We're going to get the direction from something. So we'll have some like controller that gets a direction for us. So maybe some kind of like handle input or something like that. And maybe what we could do for this is implement handle inputs. That way we know what, like, that this method is available for it, so it won't like error out completely. So we'll impl input, we'll have a pub function. So get direction. This is get like joystick, so get controller direction maybe. And we're not going to this is okay. So pub function, we're not going to have self on it because this is essentially a static function here, and we're going to return an enum, which means that we need to have that enum. Let's come up. Let's put all enums in like one place. So we're going to have enum, and this is going to be like direction. And so we're going to have left, right. Like that's pretty much left, right, no direction. So we're gonna have do a direction, and then smash types, found nothing at all. And so what I think we can do is, just for right now, we'll just say, you know what, we're always gonna return left, let's say. So we're gonna do direction left. So that means an update here. The first thing we're going to do is match on get direction. So we're going to match on what is it? Input get controller direction. And so here's where we can now track all of these. So if it's direction left, then what do we want to do here? We want to have the velocity minus equals to the walk acceleration. Walk acceleration is stored inside of Bjorn here. So we have to add that in. Walk acceleration. So net32. Walk acceleration is going to be a, let's just say 1, 0. So when we move left, then we're going to increase the velocity, I believe. Yeah, the velocity. So we do need self in this case. Mute self. Self dot velocity dot 0. So we want the first one for the x, and we want that to be minus equals to the self dot walk acceleration. And then if we have direction right, we want self dot velocity dot 0 plus equals self dot walk acceleration. And then of course we have to handle direction, no direction. Now if that happens, then my guess is we just want to reset the velocity to 0. Yeah, let's just do that. We'll just like instantly stop. So self dot velocity dot 0 equals 0 dot 0. Okay, so that should handle us for this this get controller direction. Then we want to modify the position by the this velocity. So we're gonna say self dot x plus equals self dot velocity dot 0. Now we need this resolve collision off of the world. So impl world pub function resolve collision. Resolve collision takes in a volume, which is probably an F32, like a number between 0 and 1 or something, or 0 and 100. We're going to take in an X, which is an F32, and a Y, which is an F32, and a velocity, which is a tuple, which is F32, F32. And I don't know if we need to, like, what happened? Apparently there's no return on this. I guess I'll, in this case, just return I think I should just be able to do that. It won't really matter. We're not using these. I can underscore them just so that way it doesn't yell at me too much. Okay, so let's now call this in here. So we've updated the velocity, updated this. So let's now do world dot resolve collision. And now we have to hand it the volume, which means we have to have a volume in here. F32, we have to have a volume, which is, let's just say it's 1.0. And I can't remember, does he we have this volume, but I suppose it's set at some point in time. I'll just initialize it to 1.0, maximum volume. And then we're gonna pass that in here. So self dot volume. Then our X, so self dot X, self dot Y, self dot velocity. And that's it. What are you upset about? This is an associative function, not a method, because I forgot we probably want to do mute self. Like that. Cannot borrow world is mutable. Right, so you need to be a mutable reference to the world. All right, what's next here? We resolve the collision, and then we're going to draw the appropriate sprite for our character. And let's see. So we're gonna figure out what our sprite is supposed to be, and I wonder if that should be an enum. Which means that we need to actually store the different sprites in here. Let's do maybe like a string and pretend that there's some kind. Well, we can do an enum. Enum sprites, and so that we can have Bjorn stand, Bjorn move run right, Bjorn run left. So those are our three sprites right now. We can have maybe more. Maybe I could then in the drawing stuff we could just hand it, hey, draw Bjorn, and it will just reach out into whatever library of sprites it has and draw them. So we don't have to pretend that we're importing images here. We'll pretend that those are imported somewhere else. So in update here, we have to determine which direction we're moving, and then we'll figure out which sprite we're using. So I suppose we could do like the same thing here, where we set up the sprite we're going to use, and then we're going to call graphics dot draw, and hand this sprite and hand it the location. So in graphics, we're going to have an impl of graphics pub function draw. I don't know if we need to like mutate self or anything, but we'll just do self. And we're going to take in the sprite, which is the enum sprites. And we're not going to return anything, so we don't have to worry about that. And right now, I could just underscore that, so it's just something we can call. So let's start off by the default one. If we're not moving, we use the stand. So let mute sprite equals. Now I can't remember. I vaguely remember that it's possible to do like a match with logic on the left-hand side, but I can't remember that off the top of my head. So instead, what I'm going to do is we don't have to have this mutable. We don't have to do the exact same thing that they're doing, because ifs are essentially expressions in Rust, which is super nice. What that means is I can do sprite equals, and then an if statement. So if self.velocity dot 0 is less than 0, that 0. Okay, so if we're moving to the left, then we want to return the sprites Bjorn run left. Else if self.velocity.0 is greater than 0.0, then we want to say return sprites Bjorn run right. Else we want to return sprites Bjorn stand. And then semicolon here, because we're turning from if into sprite. So now sprite is going to have one of these three things, guaranteed. And that makes the borrow checker happy for us. Because it knows that, hey, we're guaranteed, it knows exactly what we're going to have in there. And then we're going to call graphics. Yep, we have graphics here, graphics.draw, and hand it the sprite. And that makes it happy there. So if we were to sort of set this up here, we create an instance of Bjorn in setup. So this would be like game setup. Then we're going to have whatever happens in the update loop happens there. So we've created our new Bjorn. Now we want to run update, which is going to take in the world and going to take in the graphics. So we also need to create the world and graphics. So let world equals world, and I don't think we're doing anything with it. And let graphics equals graphics. Bjorn is going to stop being exactly like that. Now in update loop, we're going to call Bjorn dot update. We're going to pass it a mutable reference to the world and a reference to graphics. World, you need to be mutable. And Bjorn, you probably need to be mutable too. Are you upset because Git controller direction should have a snake case name? Oh, right, I did it the wrong way. Let's change that. Git controller direction Okay, so no errors. Resolve collision. Did I not call that in update here? World.resolve collision. Are we passing all the things? Oh. Snake case name. JavaScript and PHP and all these other languages. Okay. It's fun. Same thing for you. Have to get into my Rust sort of like mindset for it. All right, and you're upset because variant is never constructed, right and left, and that should be fine. I think I can just do underscores for right now. Right, oh right, because this is underscores to handle the fact that I don't use it. Entity is never constructed. Wait a second, this is a completely different problem. Don't. Okay, it reached out of my project into another project to tell me that there was an error there. That's cool. Let's make you never constructed. Well, then I don't care about you. I mean, in that case, if it's never constructed, we can just get rid of you. Like, can I just get rid of you completely? Yes, okay, great. Now I don't need to worry about your file. All the errors are actually errors for this file now. Okay, now we're not like trying to actually make this runnable per se. I just want to be able to use the errors, you know, in my favor here. So we have to be honest, this is the way I've been doing like game type development, is in this sort of way where we have an update method that just has all this stuff on it, which is not the best system. Now I've been doing the drawing not in its own component, but in like the main library, which so maybe this would have been better to like create my own sort of graphic system and then pass that around, then it does all the draws. That might have been interesting. But what we're gonna start doing is splitting these out into their own separate components. So it's not gonna be an ECS system per se, but it's gonna be a lot closer to that than just all in one gigantic struct. So now we're gonna have an input component that we can build as like a Bjorn input component. And I think, do we show that? Bjorn now owns an input component object, where before he was handling user input directly in the update window, now he delegates to the component. Yeah, so where is that? So he's going to use this as class input component, takes in Bjorn itself. Input component is input. So it sounds like this is just gonna be like a generic, almost singleton, where we're gonna call it like create it once. So the idea would be down here in setup, we're going to instantiate this input component. So let input equals input like this. We're going to change input to now get controller direction. Input component is now going to have an update on it. So pub function update, which is going to have a reference to self, And then we're also going to take in, now in this case, we're going to take in a reference to Bjorn. And I don't know if that's going to work for us because unfortunately, update for Bjorn, we have to get a mutable self here. So I'm not going to be able to hand a non-mutable self and a mutable self out at the same time. I could clone Bjorn, but I don't think that's exactly like the best choice either. We should probably figure out what exactly does input need for this. In this case, it's trying to update the velocity on Bjorn. It might be better to have input component return what it's supposed to do. Or if I really just want it to update the velocity directly here, I should just take in a mutable reference to the velocity and then update that directly. So let's try that. So in update, we're gonna have update. We're gonna have a velocity, and I want this to be a mutable reference to a tuple essentially. And does that work? Do I do that mutable reference there, or do I do it inside of each of these? I can't remember. And if I do this right, I'm not going to return anything. Maybe before we do this, I think I can actually run this. Let's create in Bjorn, let's create a new function here. Pub function, sort of like print location. We want to just, after one tick, we want to see that we are running to the right and we've moved. So print, like maybe print stats. We can do print as think probably. How about like print stuff, print details. I don't know. We can do self. We're not going to return anything. This is just going to call some print lines. So we're going to say x is that self.x. Then we're going to have a print line, which is, we don't need y because that never changes for us. But we're gonna carry about our velocity, at least the x of it. So we can do velocity x self dot velocity dot 0. And I don't really care about anything else with here. I just care about what is our x location and what is our velocity for this. Argument never used. Why? That's because I forgot that. All right, so now we can print the details. So what I want to do here is we create Bjorn, and then I immediately want to Bjorn dot print details, and at the end of the update loop, maybe I want to do this right here, and print the details again after we've updated Bjorn. And if I run this, cargo run, we start with x is 0, velocity is 0, and then after one update, x is -1, velocity is -1. Okay, so I think we're moving to the left, so we've moved 1 pixel to the left. Perfect. Now we want input to happen and essentially no change to that. We still want it to work exactly as expected. So we're gonna have a update function here that's gonna take a mutable reference to the velocity if it's possible for us. This may not be possible and we may have to like delegate this back to Bjorn to update its own velocity. But update could tell it exactly what to do, so it doesn't need to worry about it. So then in here, we're going to, this is where we're going to get the like direction and everything, which is still, well, now we have this get controller direction from here. So we can now set this to be a self here. We can match on this, we can do the match, and then the velocity gets updated. So we're going to take that away here. And yeah, we're not going to do any kind of handling of the collision. That's still going to happen in Bjorn here. We're just going to handle update. Okay, we're going to still handle the movement part. It's more of that the velocity is hopefully going to be updated. So we'll find out if that happens. So in update, you're back to this. All right, so we're going to match. This becomes self dot get controller direction. If the direction is left, so the direction is always going to be left. So that's fine. If the direction is left, now this isn't setting self.velocity anymore. We want this to just be velocity.0 and increment that to walk acceleration, which is interesting. This is now stored inside of this input component. So that means to me, we need this walk acceleration here. So walk acceleration, we can actually steal this from Bjorn. That also tells me we're gonna need a new. So a function, hub function new would be really helpful here. So we can say that our walk acceleration is an F32. We're gonna return a new input. And we're gonna return input walk acceleration. All right, so that should make us happy there. Chantilly, good morning. Then in main, when we create input, instead of this style, we're gonna do new, and we're gonna pass it in walk acceleration, which is 1.0. So now this happens to be a Bjorn input now. So a Bjorn input. Now when we run, what's Bjorn? Bjorn is just the name of our main character, which we're one-to-one, like sort of adding in here. We're naming our struct Bjorn because of reasons. Mainly to be easy to see like what we're doing. This is sort of like a take on like Mario, except it's Danish, I think. All right, so then we've done this. This updates our velocity. Then we want to come into Bjorn here. We need to store the input in here. And so this is Utsby, he's writing a game about ABBA. Oh yeah. Now this is interesting. Because if I wanted to store, well, I should be able to take ownership of this input, shouldn't I? Now they have me Bjorn is now storing, yeah, the input component is just owned by this. It's not like a reference to it. So we now have our input, which is a type input. So we're now gonna take in here a input, which is type input. And instead of this walk acceleration, we're gonna store the input. Which means when we come down here, so self dot, before we do that, we have to do self dot input dot update and hand it a mutable reference to self dot velocity. So now this is where we find out if the borrow checker is happy with it. This function takes 3 arguments, but 2 were supplied. Bjorn new, right, we now need to pass it this Bjorn input. No errors so far. That's a good sign. So we run this. Let's see if this works now. So if I cargo run, x is 0, velocity is 0, and then after that, x is -1, velocity is -1. So we haven't, like, nothing changed runtime wise, but we did extract out this input. So now the actual like velocity change is happening here, and it's customized per player. So if I have another sprite, like an enemy that runs around, it could have a different speed. And all I have to do is just change its input, potentially. Like if I have a player 2 or something like that. All right, what's next? That's handling this. It takes in the velocity and also internally holds the walk acceleration. Perfect. Now, splitting out the rest. So next up is going to be the physics component, which is going to update the location of Bjorn and call the world resolve collision. And then be handed like volume, Bjorn to X, Bjorn to Y, Bjorn dot velocity. Okay, so that's fine. But the physics component is going to hold the volume. It's going to figure that out. So let's come into phys. We have to create physics, don't we? All right, so struct physics. We're going to hold a volume. Might as well just steal it directly from Bjorn. We have this volume here. We're going to steal that and put it down in here. We're going to impl physics. So pub function new. We're going to take in the volume, which is an F32, and we're going to return a physics. In this case, it's going to be pretty simple. Physics with the volume in it. You were an F32, not the actual number. Okay, so that makes you happy. Now up here, you're upset because we're storing the volume. I took it from the wrong place. That's the reason why I got the error. Okay, so that should make you happy. No volume. Right. That's gonna now happen somewhere else, so let's continue on. So in physics, we're gonna have an update. So pub function update. We're only going to need a reference to self because we're not setting our volume. We're just saying our player always has this volume, or whatever object this is that has this physics always has this volume. So update, but then we're also going to need to take in here whatever Bjorn needs. So that's going to be the X position. and the world, a reference to the world. So here's where that becomes interesting. I could take in the X, and we know we want this to be a mutable reference to an F32, which is super interesting because I just want to position in memory so I can update that directly without having to borrow the entire Bjorn here. And then I also want a world, which is a mutable reference to the world. And I'm not going to return anything. So at this point in time, we want to update the velocity. So we also need the velocity here. So velocity is F32s and F32s. So we're going to say, first of all, X plus equals to velocity dot 0. Binary assignment. Oh, I need to destructure X. Destructure? No, I need to dereference X. So I have actually, not just its location in memory, but the actual value, and I can update that. And then I want to call. So that's coming to Bjorn here. We're updating this. And the next is we're calling this world resolve collision. So that happens down here. We need to pass in self.volume, self.x, so we could just pass in the x. We do need the y, so we need to pass in the y here too. So y is, I guess I'll pretend it's the same thing. So mutable reference to an F32. So this becomes a y. We need to dereference this, don't we? Yeah. Dereference, dereference, and then our velocity. Okay, that makes you happy. So now we can call physics. Well, specifically we need to now store physics. So Bjorn is going to have its own physics in here too. So physics is an instance of physics. You're going to take in this physics and you're going to own it. And so that makes you happy there. And then an update for Bjorn. I'm going to do self.physics.update. And then we're going to pass in, okay, x. So this is a mutable reference to self.x. A mutable reference to self.y. Self.velocity. And this world that sort of passed in and passed straight on through. So that worked. And then the error here is Bjorn new now needs to take our physics engine. So let Bjorn physics equals physics new, and our volume for Bjorn is 1.0. Bjorn is the center of the camera, so it's always maximum volume. And then we'll pass in Bjorn physics. If I run this, it still works exactly as expected. So Bjorn's position is still updating from that physics run. So we're, it's looking good. Things are going well. Continuing on. Next up is the graphics component. So we're going to be taking in, the graphics is going to be owning the sprite stuff. Although we have that as an extra enum. What's really going to happen here is it's going to call this a draw component. So there'll probably be some kind of like global graphics and we can draw off of there. And then, so we have an update, figure out which sprite we need to draw, and then call the graphics library for draw for that. So with graphics, and graphics is, it would need to like know what that means. So let's just pretend that we have this draw here. That's fine. We're gonna need an update now too. So pub function update takes in a self. It has to figure out which, so it needs the velocity in order to tell like what we're doing here. And that's pretty much it. We just need to know the velocity. So we have self and we have the velocity. Which is, this could be a reference, so we don't have to like constantly keep on creating it around. So it's a reference to an F32 and an F32. And I think that's pretty much it. Graphics. We could create what like the sprites that's like possible for this. So this becomes interesting. I'm not sure how I could like make this fully unique for Bjorn, because like graphics component. Oh, when I create it, I could have the different. So in here, we're gonna have standing. So standing sprite, and that's gonna be a sprites. I guess just like a sprites. We're gonna have moving left sprite, sprites, right sprite is sprites. This will allow me to separate out like graphics from like an enemy to graphics to Bjorn. So that way, hey, everyone that's a mover can needs like these sprites. An enemy gets its own set of sprites, which would then be like, okay, we're gonna add in an enemy like with this. And then on our draw, we'll have to like deal with that. Now with draw, I'm not actually going to implement that for right now, but we would imagine like this giant match statement that would basically say, okay, if it's this sprite, literally this is where that sprite is on disk. Like load that image. And in fact, we could probably put the image into the sprites here, where we can just say this sprite is, maybe we could just store this as like a tuple that holds an image. Okay, so in update here, well, this also means we need a new. So pub function new. We need a standing sprite, which is a sprites. We need a left sprite, which is a sprites, and a right sprite, which is a sprites. We're going to return a graphics module, and that is simply standing sprite, left sprite, right sprite. Okay. Now in update here, we have our velocity. We're going to call draw depending upon what sprite this is. We can come out here and just take this code and take that away. And in graphics, put that here. All right, so let the sprite we're going to use to be if self.velocity. So this becomes now just straight up velocity.0. So we're going to just track our x location. If we're moving to the left, then we want to be sprites. Instead of this sprites Bjorn left, now it's going to be self dot left sprite. If sprites is moving to the right, this is going to be self dot right sprite, and then otherwise self dot standing sprite. And then instead of graphics, this is going to now just be self dot draw and hand it the sprite that we're drawing. Okay, that should work for that. Bjorn is basically not really storing anything at this point. Bjorn will need now to have an instance of this graphics. So graphics. We'll take that in. And we'll store it. And then in update, we'll have self.physics, and then we'll have in here self. We won't need to pass this in anymore. This will just take in the world, and then we'll also do self.graphics.update. And then the velocity, right? So this will be a reference to self.velocity. Now everything that's upset about this is down here because we now need to create an instance of our Bjorn graphics. So that Bjorn graphics equals what is it gonna be? Graphics new, and then our standing sprites. So this is gonna be sprites standing sprites left sprites right. Then in Bjorn, what are you upset about? This function takes 5 arguments, but 4 arguments were supplied, so we need to hand in now the Bjorn graphics. And what's really nice about this is, let's see, graphics. We don't need to instantiate that graphics anymore. And when we call update, we don't need to pass in that graphics. It'll just now run its own graphics system. That's all it cares about. We still have 3 errors. What's next? Cannot move out of self-life sprite, which is behind a shared reference. I may need to implement the copy trait for this. And it's actually telling me sprites doesn't implement copy trait, so let's go ahead and do that really quickly. I haven't looked up, but I think I want to say that implementing copy for a enum is pretty cheap. Do I also need to implement clone? Clone, okay, so copy and clone. And now no errors. So if I run this, exactly the same thing happens. Bjorn moves 1 pixel to the left. Perfect. What is next? We've yanked almost everything out. What's left in our in Bjorn? Basically, it has its velocity and x and y, and it also has all these components. And so if we take a look at Bjorn, we have the velocity, the x and the y, and all the components. That's exactly true. So what do we have next here? Robo Bjorn. We'll take our component for handling a user input and hide it behind it. Well, now they're going to do interface type stuff. So we might be able to do that with some traits and like the dyn, like box it up and dyn it. We'll see where we go with it. So we're going to have an input component. Then we're going to take our existing user input handling code and push it down to a class that implements that interface. Right. because if we want a player input component, that's going to do one type of thing here. Like it's going to figure something out. Whereas if we have the demo input component, it does something completely differently. It has the same interfaces. Like it takes in Bjorn like that, but it's going to do something completely different. Now, right, because I want to write it differently. In this case, we have this input. I don't want to put this like logic in like the get controller direction in all of the inputs. So what I really want to be able to do is say we have player input, player input, player input, player input. It does all of this stuff, which means down here, this is going to be a player input. But now I want to create another one of these. So let's do that down here. Struct demo input. We'll have a walk acceleration also, which is an F32. We can impl off of the demo input. Pub function, might as well have a new here that returns a demo input. This one could have maybe like a default with this because we don't really care. So we're going to return a demo input with a walk acceleration of 1.0. But we're also going to need this get controller direction, like to figure out where this is coming from. And we're going to need this in like update. This is where it gets a little bit tricky. So instead of inheritance, we're going to create a trait. So maybe above our enums, we're going to create a trait type of input. And in here, we're going to have a function get controller direction that's going to take in self and maybe nothing else. And it's going to return a direction, an enum direction. And that's it. Now I could even like default, like have a default implementation for this. I don't think I need to right now. And then the other thing we want is an update, which we're going to take in a reference to self. And then what else are we doing in this input? We're taking a mutable reference to the velocity. So having velocity, which is a mutable reference to a tuple of F32, F32. And we're not going to return anything. We're just going to update that velocity. And so if I create this trait input, right, Bjorn's unhappy because we don't have an input anymore. But don't worry about that. We'll get to that in a second. Where is our input? So player input, instead of this, we do have this impl for a new player input. But I'm going to move this up here. Nope, stop. There. And now we're going to impl input for player input. And so now we don't need this pub anymore. It's sort of like default and it knows that they exist. We implement now get controller direction. We're just sort of mocking that, you know, the player input is always direction left. We have our update, which does exactly what we say that it's going to do, and it does this entire thing. And we're happy about that. Now our demo input is going to have the same thing. We're impl we have this public function new, and now we want to impl input for demo input. We're going to have a function get controller direction. That takes in a reference to self. We're going to return a direction, and we want direction. Let's do this one. The demo always goes to the right, which means we should have this not be underscored like that. Let's go change that up here. There we go. And you're no longer underscored like that. Where's our demo? Okay. So here's our get controller direction, and now we're going to do function update. This is going to be a reference to self. We're going to have our velocity, which is a mutable reference to this. We're not going to return anything. We're going to match off of, I mean, essentially it's the same thing here, is it? But here's where we can like pretend, and we can say, okay, well, what if I get controller direction? We're not actually checking a real controller. What if I overwrite this to basically say, hey, we're always moving to the right, but I could also put in some kind of other like AA logic to determine direction to go. Update is going to be the same thing. We're going to get this controller direction here, and we're just going to update the velocity based upon the self.walk acceleration. But we can update that, say like, hey, is there like an obstacle in our way? Let's jump. That would be like a direction, you know, or let's stop moving, or something like that. So I'm going to say save for this. And is there anything else that we need to handle? I don't think so. So here's where it gets a little bit interesting. We're going to need to, in our Bjorn player, it's no longer going to be an input. We're now going to have to store a box that has the dyn trait for input, because we don't know which one we're going to get. We're going to get one of the two. Bare Knuckle Waffle, good morning! So input is going to be a box with the dyn input trait here. And then we store that. Okay, so that's happy there. What's the next? All right, down here, Bjorn is unhappy because we're not boxing up this this Bjorn input, which is player input new, and that's fine. So what I need to do is box new and store this away. So wrap up Bjorn input into a box. Now what this means is I can now have a demo Bjorn, essentially. So let demo input. Now if I do this, we could run, let's run this first. And everything should still be happy. Yep, Bjorn still moves to the left. But now let's say we want to have like, if nobody's clicked a button or whatever, we want to run, like, let's restart the game, like set everything up, but give Bjorn the, this other input instead. So I'm gonna do let demo input equals box new. This is gonna be demo input new. This one doesn't take an acceleration. It just takes, like, it's got default. Like it's already defined what its behavior is going to be. Now when I create Bjorn, I'm going to add in the demo input. And this should just work because we're using that dynamic trait. So it's a little bit of dynamic dispatch because it's gonna have to look at the V table at runtime to like figure out which of those is actually being passed in. But this is how we essentially create dynamic traits and then go back and forth between them. So it's kind of like the interfaces. And now, if we run this, Bjorn ran to the right, which is exactly what we wanted. So the demo did, its own thing. And I think, yeah, so here's where this update, the AI to automatically control Bjorn happens here. I suppose what I could do to like really make this proper is let's remove this get controller direction from input here. We just have update like that. In this player input, we're gonna move you into here. We don't need like this get controller right here. Now we just have this update. And instead of this get controller right, we could just say, you know what? We're always moving to the right. Like here's our AI code to control the player. And so in this specific case, we want to say velocity.0 plus equals to self.walk acceleration. But we could like look ahead or do something else. We'll have to figure out like what that means for the player to jump, to do all of its stuff. And then everything else is going to be the same. What's our warning here? Variant is never constructed to the right. Right. I can now. Guess I could do that. So you're not there. No errors anymore. We should save. And we move to the right. This also means that I can create like a ghost Bjorn. Let's say I'm doing some kind of infinite runner, or maybe not an infinite runner. Maybe I want like a level runner thing. And I want to have a ghost so we can figure out like, okay, our timing, are we going faster or slower than we previously did? And are we going to get past our ghost? We could then have this input for like the ghost input, and it just has the list of exactly when we did each command, and it's just replaying right in front of us. That would be cool to implement. And then finally, we're going to go into no Bjorn at all. What if we, let's see, there's nothing Bjorn about it. It's just a component bag. It looks like, it's a good base object here. So now we're gonna hide physics component and graphics component behind interfaces. What do we need to do that for? Oh, right. Okay. We need to do this because what if something really cares about like what exactly it's how the graphics component is going to work, and we need to like truly have a unique graphics component for the player. So we just write our own sort of traits to overload these. So it does slow it a little bit down by having like this trait for what we have for input. Let's do this. Trait graphics function update, I think, is the only thing that we care about. And what do we need for graphics here? It's storing like the standing sprite, left sprite, and right sprite. We'll be able to like now store exactly the sprite is at new. So that'll be nice. We have draw, and we have update. So it sounds like we can put both of those in here. So we're gonna have update. What does update take in? I forgot to look. Update takes in the velocity, and draw takes in the sprite. Which this doesn't need to because, well, I guess it needs to know like which sprite we're gonna draw. So it does need to do that. So draw needs to know which sprites it's gonna be able to do, and update. So let's do draw first. Function draw takes in a reference to self and a sprite to draw, which is a sprites, and it doesn't return anything. Update, we take in a reference to self, and we take in our velocity, which is a reference to a tuple of F32, F32. And I think that's what we have here, is our graphics component just has update, oh, interesting. Has a constructor, and it has update, which takes in the game object. So in this case, the velocity is what we care about. And it also cares about this this graphics, which I suppose is the graphics module for actually drawing stuff out, which I'm ignoring for right now. We're just pretending that it happens in draw. So I'll continue to ignore it and pretend that it happens in draw. So that happens there. Let's also create the trait for physics. In physics here, all that we have here is an update that takes in the object and the world. And if we look at how we're using physics, where's physics? Here it is. We're taking like X and Y, the X and Y location, the velocity, and the world. So we need all of that. And I can just take that and put that in here. Not exactly that. Function update, a reference to self, and we're gonna do that. I don't remember, do we need, with physics, yeah, it's not a mutable reference to self. We're storing volume, but that's pretty much it. And we don't really return anything. So these are our two new traits. We're gonna do the exact same thing down here. So coming down, physics is now going to be a box, dyn physics. And with graphics, we're gonna have a box, dyn graphics. When we do new, this needs to be a box, dyn physics, so exactly the same thing down here. Box, dyn graphics. Okay, so that makes you happy. With physics.update, multiple applications in scope, multiple update found. Right, because I need to like actually properly implement this for ourselves. So graphics comes first because it's just first in the line here. We're gonna move you to be player graphics. We happen to know that these are the sprites that we need. You're gonna be player graphics. We don't need to take in the sprites anymore. We happen to know that these standing sprite is sprites Bjorn stand, left sprites is sprites Bjorn left, and you are sprites Bjorn run right. But now we need to implement this off of here. So impl, what is this? Graphics for player graphics. And we can get rid of the pub here. We have function draw. It takes in this sprite. We have this function update. We take in this update, and we're happy here. We can now run this and do all the things with it. If we need a graphics for something else, like some enemy, we can now implement that graphics for that enemy, and it does its own specific thing, which is fine. All right, we have the player input, demo input, we have all that stuff. Now we have the physics. So we're gonna change this to player physics. Pub function new. We don't need to store the volume anymore. We are just going to say, hey, when you're a player, we know what volume we're going to set you at, which is 1.0. We define this here, or maybe in some other like configuration file that we can directly reach into when we instantiate the player physics. And then that's the end of you. And we can now impl physics for player physics. Take away this pub function, and everything else should remain the same here. Now we need to update all of these things with the game setup. We have the Bjorn input. We're still using the demo input for this, so the AI input. The Bjorn physics now needs to be boxed up. Okay, that's fine. Also, we don't need to hand you that anymore. And you are player physics, and we need to box you up. So box, no, not like that. Parentheses, colon, new. Like that. And then it's gonna be the exact same thing. So you're gonna be the player graphics, new, and we don't need to pass you in anything. You just happen to know what you are. And we need to box you up. So box, new, like that. And then you're all happy. ZSX, good morning. Oh, thank you. Thank you, ZSX. Yeah, no, this is good for me. I hope it's good for all of you too. I hope this is something that we can all learn from and like improve our Rust code with. And I really like doing like game development stuff to learn better programming tactics. All right, so we boxed all that stuff up. No error messages. Everything is still just working, except now, where is it? We have this struct Bjorn. We can now rename Bjorn to game object. So instead of this impl Bjorn like that, this can now just be game object. And then down here, so we have all this like input and all these things. We now create a Bjorn from a game object, new, and then it just works. So if I want to create an enemy, it's going to be very similar. I could just down here and say, let maybe we have like we'd still have to have like physics and graphics and everything else for whatever we're passing into this. But let's say I have a like a crawler. So let mute, or we can do it like a dragon. So we have like a dragon enemy that flies around. So let mute dragon equals game object new, and then we have to give it its location. Well, maybe it's like at the top left of the screen. So it would be 0.0 and 0.0. And now we need to give it like all the inputs and everything else that we have. We need a dragon emote. If I find like a good emote for that, maybe I'll add that in. I do need to create the emotes. I have a list, like a sticky on my wall for creating emotes. All right, so now we need to create these inputs, physics, and graphics. So let our dragon input, and this is actually, well, the problem here is that I didn't create like these for everything else. But if I did, like we could have this dragon input, we have dragon physics. I would want to like replace this with like dragon physics. And this with like a dragon input. These don't exist, unfortunately. And then I could pass in here our dragon input. What's next? It is input physics and graphics. So then dragon physics, dragon graphics. CM Griffin, good morning. All right, and then I'm just gonna comment all this stuff away because we don't actually have those objects. We can't do that. But like that's the general idea, is like we could now create a bunch of these game objects from this like generic game object struct that we created. And you know, it's not object-oriented code, it's a lot more component-style code, but we're still getting the benefit of like interfaces using these traits. And yeah, it's a little bit slower because we're using dynamic dispatch, but that doesn't really matter because the games we make here should be really good. Now, if we like implement a billion items and then we run into problems, we're probably going to need to switch over to a true ECS system as opposed to these components. But I really like these components. They look really nice. So if we run this one last time, we'll see that our demo Bjorn here runs to the right. And if we had dragons, we could see them like flying around and doing their own little dragony things. So that's what I have. And I think that's the end of, let's see. Yeah, we already did these re-implementing of these things, and then there are all these like things to like consider with like how they're gonna communicate with each other and how they're gonna do all that stuff. But a really quick sort of overcap of what we did. In the end, what we have here is we have some traits for any of the components that we're gonna use. We don't have any singletons. We have like, okay, an input that's gonna handle input, but it's gonna be different based upon what type of creature it's gonna be. So the AI is gonna go into the input. We also have like graphics, which is gonna be different per character because it's gonna know what the sprites are that it's gonna use. And then the physics is gonna know the sound that needs to play and also like any of the collision stuff that it needs to deal with. And I create these traits so that way later on we can store instances of those objects, but box them up and basically not have to worry about which type is being passed into the game object. And then the rest of it is just implementing them for the specific use cases that we have. And down here is how we would say in a game setup, we just create these and in the update loop, we run them. All right. Let's see. Catching up with chats. ZSX, last time we worked on a game was Daok. I'm not familiar with DAOC. Can I check in and let you pull down the code? Absolutely, let's do that right now. Let's open up, get cracking. I have saved. Here's all this. So we implemented, I guess, like component chapter in Rust. Save that, push that up, and I believe I have a command called bang repo that will show you where that code is. It's in, it's on the master branch, and it's in Playground's component example. Oh, Chantilly, you already got it from me. Thank you so much. Let's see, anything else? Oh, Dark Age of Camelot. You did the Linux network code? That's awesome. I never played Dark Age of Camelot, but I heard about it. And I like saw a bunch of the images, but I wasn't like playing very many games at that time. So that is pretty cool. Well, with that being done, I wish I could stay longer, but I do have stand-up to get to, and I have like my entire normal day that I have to do. So I'm going to go ahead and switch over to the ending screen. Thank you everybody for stopping by and watching this. I hope that it was helpful for you. I put that like the link to the code in chat, and I also have the link to the code in the VOD description that goes into YouTube. So if you have any questions, please ask me in the comments. You can tweet at me or anything else. I do not like advertising on projects, especially for those type of things. So I'm going to, how do I delete that one message? I don't know how to delete that one message. So I'm just gonna have to do a quick timeout.